Hey everyone, and welcome. Today, we're diving deep into something that's at the very heart of Java, the constructor. You know, every single time you create an object, one of these is working behind the scenes. So let's peel back the curtain and really understand what's going on.
You've probably typed the word new a million times, right? But what's the magic that's actually happening when you do? That's the big question we're tackling today. It's all about bringing an object to life, and the constructor, well, it's the director of that whole show. So, let's start at the beginning with the object blueprint. In this first part, we're going to nail down what a constructor is and why it's the absolute starting point for every object you'll ever make.
Okay, so what is a constructor really? Well, you can think of it as a special kind of method. Its one and only job is to get a brand new object ready for action. It initializes the object state, which is just a fancy way of saying it gives starting values to all its variables. It's kind of like the setup crew for a concert. They get everything plugged in and ready before the band comes on stage.
Let's look at this simple line of code. So much is happening here. When you use that new keyword, Java first goes and carves out a chunk of memory for a student object. Then, immediately after, it calls the constructor. In this case, it passes in Rohan and 21, and the constructor uses those values to set the name and age fields. And just like that, our S1 object is fully formed and ready to go.
All right, so now we know what a constructor is, let's dig into how to build one the right way. This section is all about the non-negotiable rules and the different flavors or types of constructors you can create.
Okay, these are the 4 golden rules. They're simple, but you gotta know them. First, the name has to be an exact match for the class name, period. Second, and this trips people up all the time, there is no return type, not even void. If you put void, it's not a constructor anymore. It's just a regular method. That's a classic bug. And that 4th rule, overloading, that's where things get really powerful.
And that brings us to overloading. Just like with normal methods, you can have a bunch of different constructors in the same class. The only catch is that each one has to have a different list of parameters, either a different number of them or different types. This gives you a ton of flexibility in how you create your objects.
And check this out. It makes perfect sense when you see it in action. If you call new student with nothing inside the parentheses, Java knows to use that first door. If you pass in just a name, it uses the second one. Pass in both a name and an age, and bam, it picks the third. Java figures all this out for you based on what you give it, which is incredibly useful. So what if you don't write any constructor at all? Well, Java's got your back. It'll provide a default constructor, totally free of charge. This one takes no arguments and just sets your variables to their default values, like 0, null, or false. But, and you have to remember this, the second you write even one constructor of your own, that freebie from Java disappears. Poof, it's gone.
Next up, we're going to talk about one of the most powerful and sometimes kind of confusing keywords in Java, this. When you use it with constructors, it has a couple of really important jobs to do.
Its first big job is to enable something called constructor chaining. So instead of copying and pasting the same initialization code across multiple constructors, you can just have one constructor call another one in the same class. It's awesome for keeping your code clean and making sure all your setup logic lives in one central place.
Now, there is one massive rule you cannot forget here. The call to this must be the very first line of code in a constructor. I mean it, the absolute first statement, no exceptions. This is to make sure that the main object setup happens right away, before any other logic gets a chance to run.
So just to recap, this is like a little Swiss Army knife. We just saw how this.fromArg is used for constructor chaining, but its most common job by far is to tell the difference between an instance variable and a parameter when they have the same name, like this.name equals name. And finally, you can also use this all by itself to pass the entire current object as an argument to some other method.
Whew. Okay, we've covered a lot. But now, let's throw a wrench in the works. What happens to constructors when we bring another huge concept into the mix, inheritance?
All right, listen up because this is super important. Constructors are not inherited. A child class does not automatically get its parents' constructors. And this is the key. For a child object to even exist, its parent part has to be built first. This means the parent class constructor always runs before the child class constructor.
Let's walk through the play-by-play. When you type new childhood, the very first thing that happens, often invisibly, is a call to super. That call kicks off the parent's constructor.
The parent object gets fully built first. Only after that whole process is complete does the child's constructor code finally get to run. The rule is simple. A child can't exist without a fully formed parent.
And, hey, don't just take my word for it. Here's the proof. If you stick a simple print statement in both the parent and the child constructors, and then create a new child object, the output on your screen will always be parent constructor called first, then child constructor called, every single time.
Okay, you've got the fundamentals down cold. Now let's level up a bit and look at some more advanced patterns, and also see how modern Java is making our lives a whole lot easier.
A really classic pattern you'll see out there is the singleton. The whole point is to make sure you can only ever create one single instance of a class. How do you enforce that? Simple. You make the constructor private. That stops anyone from just using the new keyword. Instead, they have to use a static method you provide, like getInstance, which gives you total control.
Now, for a long time, we had to write so much extra code just for simple data holding classes. But let's talk about the future, which is already here with Java records. These things are a total game changer.
I mean, just look at this comparison. On the left, the old-school class with fields, a constructor, getters, so much boilerplate. And on the right, the Java record. You literally just declare the fields you want, and that's it. Java automatically generates the constructor, the getters, and even the equals, hash code, and 2 string methods for you. It's an incredible time saver.
We're in the home stretch now. Before we wrap this up, let's do a quick run-through of the most common mistakes that trip people up with constructors. Avoiding these is going to save you a lot of headaches, trust me.
Okay, here's your checklist. Remember, this or super has to be the first call. Don't accidentally add a return type. Be really careful you don't create an infinite loop where 2 constructors call each other. Remember, constructors aren't inherited. And finally, if you add your own constructor with parameters, you lose that free default one, so add it back manually if you need it. So let's end on this thought. Constructors aren't just a formality. They are the absolute foundation of every single object in your program. They guarantee that your objects start their lives in a valid, consistent state. So the real question you should ask yourself is this: are your constructors building on solid rock, or are you building on sand?